All right, I just wanted to show this. I've been running the pump now for a good several hours. It's gotten to steady state. Just wanted to see durability wise how things work, and honestly it's kind of an excuse to play with the FLIR. Obviously you can see this is the electric motor here. Leads coming off. That's my 12 volt power supply. It's amazing how that actually shows up. And it's been running constantly. It's a 97 degrees. It looks super hot, but really about 130 degrees. Room temperature is about 80. That's the table surface there. So rescaling, you can see how I can get the rescale here. So I just wanted to see how this pump would handle it. So this pump here is on Volkswagens and Audis. It's actually used for the intercooler on some of their, I think also Mercedes uses it too, because they use a liquid intercooler on their supercharged engines, supercharged and turbocharged motors. And so this pump circulates for that. Through here you can see not much going on, coolant flow. Rescaling again there. That's pretty neat. You can, how much you can see with this IR. Some things will show up as hot because one thing with IRs, it's very sensitive, fairly sensitive to surface finish and the emissivity of the surface. So this is aluminum and it shows up quite a bit colder. Curious if I get my thumbprint on there. So it's registering me at 99. It's not really picking that up just because the emissivity is really low on scale. One trick that you can do for that, so you see the motor, you see it looks like it's cool on either side. That's actually not a cooler spot. That's because I wrapped tape around it, and that tape has a nice matte finish with a consistent emissivity. So I'm just peeling the tape off there. So if you were looking at IR and you were looking at this metal surface, you go, oh, it's really, really cool. Even though when you put your finger on it, it's obviously not. So I put the tape over it, just a simple blue masking tape, and so it's been running for hours, steady state. Obviously, it's not that warm in here. It's about 80 degrees, but this is staying at a nice stable temperature, and this is made for continuous duty applications under hood. So, and the coolant flow is certainly adequate for this application. Get it to rescale here again, but yeah, past that, I am going to try. So one of the things, the motor is air cooled. It doesn't really get any cooling from the liquid. The pump and the pump bearings are very likely liquid cooled, so you don't want to run this dry. They may be lubricated by the coolant. Good way to kill these typically is running them dry. You may not think it's dry, but if you get an air pocket right here on the inlet, then it can't pump through. So let's make it a rescale. So it's not quite calibrated because my hand's obviously not 103 degrees, but certainly more than what I'm using it for. But this type of cooling system is really what you're trying to do. There's not a lot of heat that you're trying to dissipate from these batteries, just as a function of the transfer, especially at standard discharge rates. There's just not that much heat. Roughly, say 98%, or at least well over 90% is of the chemical energy is being transferred into electricity, with that remaining, let's say 5 to 10%, depending on discharge rate, coming out as heat. But part of the key thing for balancing is keeping things at a constant temperature. Also, when you do large discharge, so if you stomp on the pedal for 5 or 10 seconds and get up to faster than you should, that will dump heat into the batteries, and this just helps to redistribute that. Again, for normal applications, I really don't think you need the radiator, and just circulating the coolant is just fine. One of the other things too with this, I don't think I'll add it, but it's good about the liquid cooling is you could add a heater in, because if you want to charge these in cool climates, then you definitely, or cold climates, then you definitely want to heat the pack or keep the pack above freezing. A good way to kill these is if you try to charge while the cell temperature is, the exact temperature vary ranges, but if you're getting close to freezing temperatures on the actual cells, then you don't want to be charging, or at least especially not fast charging. And that's the nice thing with the volts is that maybe you can see how well you can see on this IR, but this is the BMS pins, and there are thermosistors. I can't remember if it's thermosistors or thermocouples located in the pack, so you can monitor the cell temperature. Anyway, the bench test is successful. I'll come up with a cleaner design and something that can be redeployed on silent. Interesting how the edges show up like that, but I think that's the FLIR camera combines the IR and the visual spectrum and highlights areas, but that's all for now.